This podcast is going to look at an area problem. The problem is this. A rectangular swimming pool is 3 times as long as it is wide and is surrounded by a deck 2.5 meters wide. Find the dimensions of the pool if the area of the deck is 265 square meters. So we're given the area of the deck and we're asked to find the dimensions, or the length and the width of this pool. To set this problem up, I'm going to take the area of the deck, which is the gray region in the picture here, add it to the area of the pool, the blue region here, to get the total combined area of both. Okay. Now, from the given word problem, we know that the area of the deck is 265 square meters. We also know that the deck is 2.5 meters wide, and that's going to help us find the dimensions of the total area. We're also told the length of the pool is 3 times its width. So in this problem, since I don't know the width of the pool, I'm going to let the width be represented by the variable x, and therefore the length represented by the expression 3x, because the length is 3 times the width. Okay? Now, as I said before, the area of the deck is given. That's the 265. The area of the pool, since it's rectangular, can be found by taking its length times its width, the formula for the area of a rectangle. And the length in my picture is 3x multiplied by the width of x. Now the total length of the pool and deck combined can be found by taking the length of the pool, the 3x. So in this diagram here, the 3x is the red line segment, plus the 2.5 meter width of the deck on each side. So the total length is this blue line segment, the 2.5 meter width, plus 3x plus 2.5, or 3x plus 2.5 plus 2.5. The total width of the pool, or excuse me, the deck in the pool, is the width of the pool, the x, plus the 2.5 meters of decking on each side of the pool. So the total width would be x plus 2.5 plus 2.5. We can simplify this equation. First of all, I'm going to take 3x times x. The product of that would be 3x squared. And I'm going to combine the 2.5's in the parentheses here so that I get a binomial, 3x plus 5, times another binomial, x plus 5. I then take the binomial times the binomial using the FOIL technique. 3x times x is 3x squared. Outer, 3x times 5 is 15x. Inner, 5 times x is 5x. And lastly, 5 times 5 is 25. To get this equation, simplifying it further by combining like terms in the trinomial on the right-hand side of the equation, I get 265, the area of the deck, plus 3x squared, the area of the pool, equals 3x squared plus 20x plus 25. Now it's just a matter of getting x by itself so that I can find the width of the pool. So I'm going to subtract 3x squared from both sides of this equation. By doing that, the 3x squared on the left-hand side cancels, as does the 3x squared on the right-hand side. And I'm left with 265 equals 20x plus 25. Now I'm going to subtract a 25 from both sides. And by doing so, I get 240 equals 20x. The 25's cancel here. 265 minus 25 is 240. Finally, I'm going to divide both sides by 20 to isolate the x. 20 divided by 20 is 1x. 240 divided by 20 is 12. So x equals 12. X represented the width of my swimming pool. So the width is going to be 12 meters. The length was 3 times the width, or 3 times 12, is 36 meters. So our final answer in this problem, the pool's dimensions are 12 meters by 36 meters. And that would be the final solution to this area problem.